welcome, good morning. My name is Sebastian, and I'm very happy to be here. And yeah, very happy to share a topic that I'm very passionate about and that Lefter wonderfully introduced, which is privacy, or as Vitalik likes to say, make Ethereum cypherpunk again, right? So I'm very happy to talk about that. And yeah, I'm here today to talk about Gnosis VPN, a Web3 era VPN without central points of data availability, failure, or control. And this work is made possible by GIP 98 for Gnosis DAO. It's a Gnosis improvement proposal that was passed about 3 weeks ago. And I'm very grateful for the support from Gnosis DAO. And I wanted to say thank you for everyone here who might have voted for us with their GNO to bring a new product to the Gnosis 3.0 ecosystem that we've seen outlined before. And yeah, that is our contribution. Gnosis VPN will run on top of the decentralized Hopper network, and talk a little bit now about what this is and why we need all that. But I would like to start with a personal announcement, actually. So in light of this GIP 98, I, next to running Hopper and supporting the team, joined Gnosis as VP of Technology. So you'll see me in a little bit, less yellow and more Gnosis swag going forward. Yeah, thank you for that, and I'm really happy to be closer and joining the Gnosis family more closely, because I would say there's few ecosystems that are as aligned with my personal values, of bringing this cypherpunk mentality to the wider Ethereum ecosystem. I'm very happy about this. All right, now, Gnosis VPN, right? Privacy, I get it, it's an early morning slot, 11 a.m. Privacy, do we really care? Well, my motivation for the next 20 minutes is to show you something that might motivate you to use Gnosis VPN and related solutions. So first of all, privacy solutions, right? So privacy problems. So Web2 infrastructure is harvesting metadata. Nothing new, you know that, right? I would like to highlight two words here. The first one is metadata. So Web2 is not just harvesting your data, right? So if you upload pics of you in your drunken teenage times to Facebook, that's not great. And looking at the room, I think most people here learned that by now. But the word is metadata. Metadata is really about who you're talking to, what web services you're accessing, and information about your device and your connection. And that is really a problem, because you can be tracked across domains. And this cross-domain tracking, I find really scary, right? So observing your browser, observing your connection data gives providers the ability to fingerprint you, to single you out, to identify you as a person. And I find that broken, that this information can travel across domains and used to track your every move on the web. Now, okay, maybe some of you knew that, I get it. The second word I would like to highlight is infrastructure. Right? This isn't just about the Facebook or how my mom sees it. It's a funny thing that you do in your free time. The web is running our society, right? We live in a digital world, not just for TikTok, but this is how de facto our modern society runs. And collecting data about that is not just collecting data about me, my hobbies, and my quirky teenage times. It is about the underpinnings of our modern society, an increasingly political world. And that is broken, right? So information should be available, but data should not just be tracked. So as some people like to say on the web, well, data is the new oil. Well, I would say it's more the toxic waste. We need less data about us out there. And that's what privacy is about, to retain data, to retain it and not share it with the world out there. So privacy infrastructure is needed so that Web 2 infrastructure, which is private for-profit corporations, typically it's not nation states, right? It's not nation states, it's powerful corporations that run the web, cannot see everything we do in this modern world of ours. Luckily, it's not that bad, right? We have a solution. The solution is nation states and violates. Why? Well, because we have enforceable laws and regulations that enforce privacy rights, right? We Europeans here have GDPR, and GDPR is great. You can go to Facebook and, tell Facebook, well, you can't do crazy shit with my personal pictures that I uploaded there. And that works, right? Believe it or not, that actually works, and that's great. Now, along comes Web 3. Along comes decentralization. Along comes peer-to-peer. And along comes unenforceability of these laws and regulations that we established our web to kind of work with. That's a problem, right? So we live in a cypherpunk world where we have unknown third parties that we interact with peer-to-peer networks, and that makes it actually way harder to enforce our privacy rights that protect us as an individual. Facebook could be, and did get put in front of court for millions and sometimes billions of dollars because they were fucking around. Well, how's that going to work in the Web 3? It is going to work by building on strong privacy tech. And Lefteris was bringing some motivation for that and showing you, how your IP address can be used, and if you don't watch out, and if you rely on centralized services, how that leaks, and how that's not great and being potentially used against you. And we have seen the NFT example. I'm now going to show you another one. And another way of identifying you as a user. So I guess we have some Rotkey users here in the room, but I guess we have also some people that use tools like, say, Uniswap. Any Uniswap users here in the room? Yeah, a few? Okay, good. So, it's portfolio trackers, it's public, decentralized applications. Let's see what's going on under the hood there, and even if you think you're an anon, how that can be used against you. So I'm going to introduce a new form of Web 2 to Web 3 fingerprinting of users. So we have a website that is, having a beautiful logo that's called My Token Tracker, and just like other token trackers, you guessed what it does, right? So it shows you your portfolio. So I picked a random address here, and I'm going to check out the portfolio. So you see it's some address, it has more ETH than many people, and it has a bunch of other tokens. It's a Dong coin, very funny, right? Has a very funny icon here. Yes, was entertaining. All right, so how does a token tracker work? Well, it just fetches all this information, displays it for you. Nothing new, right? You're all aware of it. Basically, every single dApp that you interface has some features like this, showing you which assets you have, being nice to you, showing you a little icon that you don't go for, for scam coin. It's actually great because you don't want to trade with the wrong USDC, so it's good if you see the icon there, to know that this is the right USDC. Maybe some people have a feeling for where I'm going with this. So what happens here is, and I show this now on the right-hand side of the screen, is there were a bunch of requests that were being made, and I'll just start this here again. As I do the search, you'll see how on the right-hand side there's some requests popping up for specific icons, right? Now, what we render on the right-hand side is actually all the requests that are being made to the server here to obtain the icons that you see on the left-hand side. And along with these requests, and again, this is nothing new to anyone here, I know, you disclose your IP address. You disclose your user agent, so you learn something about my operating system, my browser, and a whole bunch more that we don't show here, just to keep it simple. You see a Swiss IP address because I'm currently connected to my Swiss mobile hotspot, because I sometimes don't trust the conference Wi-Fi's. So this address is actually the largest safe there is. I think it's the Bitfinex, some Bitfinex hot or cold wallet, I don't know. Yeah, and we see that it has a bunch of tokens on it, of course. Now, the interesting thing that I would like to highlight is this information goes to third parties. As you interface a dApp, the same thing happens, right? Any sort of dApp you go, it loads token icons, and it loads that typically from third-party services. Now, what can they infer about you? They just load the icons, right? But as it turns out, these icons here, and that's how we have also displayed it, are unique to the tokens. So what is the anonymity set of you there, as you as a user? Basically, we could go ahead and say, OK, imagine you're that service provider, right? And I'm going to pretend I'm that service provider now, and I'm going to try to figure out who you are, only looking at the tokens that were loaded from the app. By the way, that service also knows from which web service that was loaded. So we've prepared a little Dune query here. And on this Dune dashboard, you see a bunch of tokens. So you can kind of customize this Dune query here. I selected 9 out of the 10 tokens that were loaded. I left out the OMG because it's a very popular token, and that's being held by a lot of addresses. And what we're basically doing here is we're in this bar plot on the bottom here, we're saying, OK, the left-hand bar shows if at least one of these tokens should be in a set, how many addresses hold these tokens? And it's indeed 54,000 Ethereum addresses that hold at least one out of the 9 tokens on the list, OK? If I say, OK, I want to have 2 tokens on the list, we're already down to 1,000 Ethereum addresses and so on. And indeed, the interesting thing here is, if we go all the way up to the 9 tokens on this Bitfinex address for which an icon was loaded and available, we see there is a single address left. Anonymity set 1. I singled you out by a fingerprint of your tokens. Not loaded through an RPC call, not loaded by any fancy MEV thing, not actually touching the entire Gnosis or Ethereum chain at all. Just loading at Web2 kind of metadata that are around while you interface an app. And what you see here is the remaining address. If you change different tokens here, you will see it's fewer addresses. And if we, yeah, I don't have it here, but if you can check it out yourself later. So this is the Bitfinex address, which is this safe that we highlighted here. All right, now that's pretty bad, right? That's not great. But is this real? Is this really a problem? Let's see. So let's take a quick look at Uniswap, and let's see what happens there. So I'm going to load the DevTools, and the most interesting thing I'm interested in is the network tab, right? So in the network tab, you see everything that this page is loading, and this is the default view of Uniswap. I am going to open this dropdown here, which shows a bunch of icons. Now, I don't have my wallet connected yet, so that's why it just loads the default set of tokens. If you do connect your wallet, it loads the tokens which you have on your balance. Now, where do these icons come from? Well, let's see. OK, it comes from raw.githubusercontent.com. Now, who is githubusercontent.com? It's probably good guys, right? It's probably some devs that have your best interest at heart. I don't know. I'll leave it at that. So basically, many dApps, this is not a dunk on Uniswap, right? Many dApps do exactly this. They are using a third-party service to query data from some other Web2 source. And that can use now, like raw.githubusercontent.com knows this is you. They know what you're using, which is Uniswap. They know everything you do in real time. And they can track you no matter what you do. Now, that is a little bit broken in my eyes. All right. So after this first part of a demo, you might say, well, what about centralized VPNs? Well, centralized VPNs is basically shifting the responsibility and the trust in one web server which we just didn't trust because we were just going through them doing bad things, with another one. That's called a VPN. Sure, the VPN is good that it doesn't disclose your data to this third-party operator, but typically they can harvest data in just the same fashion. Not great. So obviously, this is not just Web 2, this is also Web 3, right? So as we say, privacy loves company. You need something that is not just actually relaying data via one server. Because if we think about this anonymity set, right? So how many people could, how many users could this be? If I'm trying to find out among how many users I'm hiding, I have to consider, let's say, a popular Web3 app. Let's say Uniswap, right? So hiding behind a VPN means actually my activities are being mixed up between people who use the same RPC provider, so who are connected to Ethereum mainnet via, for example, Infura, using the same VPN provider, but actually not just provider, but also that very server at the same time. I can guarantee you, you're probably alone. So a VPN does not help you if you intend to unlink your activities across domains, which I think is a primary problem if we want to, avoid being tracked in the Web3. So how do we improve that? So this is where I will give a bit an overview of how Gnosis VPN is envisioned to work. So on the left-hand side, we see user device, right? So you might have your browser open. In your browser, you might run CalSwap. Maybe you have a dedicated app for some things. And in this dedicated app, you're using some Web 2, Web 3 services. And this should get a secure access to other web services, right? So we don't want to break that. We don't want to break the entire stack. It still has to work. And that, as we'll see in a minute, is sometimes a bit the challenge. So on your device, you will have a Gnosis VPN client running, which is working very similar to a standard VPN. So neither you nor your operating system needs to understand what is going on here. So the Gnosis VPN client is sending data via this underlying hopper network, which has multiple hops through which it is sending your data. So it's not just relying on a single server. It is multiple hops that people run, for example, on their DApp nodes at home if they run a hopper node, until it's hitting a Gnosis VPN exit node that is making then a secure request to the web servers. And the interesting part is you can do that in an end-to-end secure way. So it's not just private, but it's end-to-end secure. So there's something called TLS. It's what secures it's the S in HTTPS that you might see in your browser. And so that is how you securely communicate end-to-end encrypted. Now the problem is, people might ask, well, why do I need to install this on my laptop, right? Well, the problem is that your browser, unfortunately, doesn't give you full access to this low-level stack that would allow us to establish a TLS connection over Hopper directly. That's why we need a dedicated app that's installed on your laptop. But otherwise, it works in just the same way. But because there is no single VPN server, it's being routed via multiple hops in this Hopper mixnet. You don't have single points of failure or single points of data availability, which basically means data harvesting potential. I don't talk much about Hopper here. You can find more information about that. It's a mixnet, I will say. So data packets are not just being relayed directly, but on every hop, they're being mixed in the traffic. And that's how Hopper is more private even than Tor. Cool. This is actually a hard problem. And since GIP 98 passed about 3 weeks ago, I will not be able to give you a full demo of that. We have a first milestone at the beginning of next year. And I just quickly wanted to talk a little bit about why this is hard. So there's a thing called the anonymity trilemma. So what we want typically is strong anonymity, that's kind of clear, low latency, and low bandwidth overhead. And we want to get all three of them. So that is hard, and you have to make some trade-offs here to get that right. So for example, you can imagine if data packets are hopping through multiple hops in this network, that takes longer time than a direct connection. But you do get stronger anonymity for it. And likewise, if there's more traffic going through this network and through a node, you have more bandwidth overhead. So if you have a metered internet connection, that's not so cool. But again, it gets more private, potentially with shorter latencies. That's basically what this triangle is about. Additionally, as a user, you want kind of protocol agnostic integrations. So you want to use this for web services, like CowSwap, but you also want to use it for streaming services that don't use HTTP, but different transport protocols under the hood. And finally, you want seamless UX, right? So you want this thing to not be too quirky on the integration, and we will get that right. But that will take some time, and that's why we're working on a step-by-step approach here. Now, the first step to get there we call actually unlinked HTTP, and it's something that I will also show again in a second. It's just my little screen here is turning off. All right, so what is unlinked HTTP? Unlinked HTTP, you could say, is a very early precursor of Gnosis VPN. And it allows you to not protocol agnostically, as I just said, but in a specific purpose fashion, make HTTP calls, so what your browser does when it fetches these funny icons, for example, that we've seen, or web content from a web server. And that is already possible right now. So you use this unlinked HTTP library. You can directly integrate it in a browser. You do not need to install anything on your laptop, so that's kind of cool. Yeah, and with that, you can fetch content that is being served through the Hopper network. Now, I also want to be clear, there's a bunch of caveats here. So in this first version, Hopper Association is both running the entry and the exit nodes. So that is centralized, yes. That is not better than Tor, but it is already better than a VPN. And we'll see in a minute why. But yeah, so there's a bunch of caveats. This is not the final version. It's worse trust assumptions, it's more centralized, and it's less performant than I hope the final version will be. So let's get back to our token tracker, right? Because our token tracker, you could see here on the right side, it exposes my IP address. So right, I made this search, it requested these icons from a web server, it got the response and could render them, and it disclosed my IP address. So what we have actually integrated in this token tracker is exactly this UHTTP JS library. So what this does now is, let's see if it works, because this was deployed by the guys like 2 nights ago, I think. Yeah. So what you see now on the right-hand side is, so first of all, you saw that the icons did reload, right? It was maybe taking a second longer or so. But we do see on the right-hand side is not my IP address anymore, but like a bunch of different IP addresses which are serving these individual requests. So yes, they're all in Helsinki, because apparently that's where the data center is, where we host these exit nodes. But you can see why this is better than a VPN, right? So this is like a VPN where you switch your VPN server for every single HTTP request. So if you do a VPN, switch it on, off, on, off, on, off, and switch the server, cool, yes, this is about as good as UHTTP is today. If you can't, switch your VPN server with every request, well, that's the way to go. And sure, that's not many addresses, right? So we have, I think, currently about 5 exit nodes here for demo purposes. That's where you see some IP addresses being repeated. But even that one, so what does this mean, right? So even this exit node doesn't see you, because there's a multi-hop relay. So in this demo, we have 2 Hopper nodes through which this is relayed. So even this exit node doesn't know you, right? They can link you because they got a data package from another intermediate machine. Good, so that was a quick demo of UHTTP. And as outlined here, this is not, it's not great. On the other hand, it's actually kind of cool that this works without installing anything on your browser. And the actual trust assumption of this should be that this exit node should work alongside a web server, right? So this thing should kind of run on premises of any web application. So if you want to check that out, please come talk to us, or one of my colleagues from Hopper running around here, and happy to see how we can make that happen to bring privacy to a web application that you have in mind. And yeah, finally, if you like this, we have a few more demos. So Lefteris talked about the problems with NFTs. If you want to mint yourself a non-private NFT, you can do that at mint.hoppernet.org. It's going to take a minute to load this. So you see a few metadata of mine here. Or if you want to check out what your wallet is doing or docs your validator, you can find it out. The website is called gnosisvpn.com. And yeah, with that, I would close my talk. Thank you again so much, Gnosis DAO. Thank you, Gnosis. Thank you, all of you, for your attention, and make Ethereum cypherpunk again. Thank you.
Thank you. Thank you, Sebastian. I'm thoroughly scared now. When Gnosis VPN? Do we have any questions for Sebastian? Right here in the middle.
Thank you. This is looking great. I was wondering if you could talk a little bit about privacy for validators, which is a great concern among DApp node users. Like a lot of them are very concerned that like their ISPs are going to know that they run X amount of validators and that like their funds are going to be like dogs. So I was wondering if you could talk a little bit about the project, but from validators' perspective.
Yeah, happy to give you a quick TLDR. The quickest is it's worse than you think. So validators on Ethereum are not private, right? So we did an experiment. So we took a Lighthouse client on Gnosis chain, modified it such that on every attestation, which happens once per epoch, we harvest and store in a big database your pub key and the IP from which you got it. And with that, we can link the two, right? So and that's actually kind of messed up, because with this, we could identify all of our team members were running actually DApp nodes in their homes, so we could correctly identify, even without crazy, data science approaches, the IP address of every of their pub keys. Why is that bad? Because it's also in Ethereum known ahead of time when is your slot to produce a block. So I know it's this guy's turn to produce a block, and I'm right after them. So I can DOS them or attack them in any other way for 4 seconds. So 4 seconds is so short you will not realize that your Netflix stream was even blinking, right? So you don't even realize it. But for some reason that you don't understand, you missed a block. And the guy after you is kind of happy because they had these high-value transactions and MEV rolled over. So yeah, that's a problem. Now, I want Hopper to solve that. We will get there. We consciously chose to go for the execution layer first because that is extremely latency sensitive. So you have only about, actually not even 4 seconds, so you have around 2 seconds to publish a block. And if you mess that up, for example, because you have a privacy-respecting transport layer, well, then you just missed your block rewards and you're going to be very pissed off at your setup. And I don't like dealing with very pissed off people. That's why we started with something that's a little bit simpler. Optimize the system. I'm quite confident that we will eventually get there, but it'll take us some more time. I would say the distributed validator tech projects out there, Divas and so on, they made this work. They are battling with similar problems, so that's why I'm confident we will get there also.
Another question for Sebastian? Right here.
Just an easy one. What's sort of the number of Hopper nodes that you would like to see for good anonymity now and in the future?
Yeah. So currently the network has a little over 400 nodes online, and that's quite nice. That's quite nice. There's 2 reasons for which I would like to see high numbers. The first one is anonymity set, right? The larger the set of potential routes in the network, the better it is. And the second one is bandwidth. So actually a network like Hopper, unlike blockchain, has pretty cool scaling properties, right? It's perfectly scalable in the sense that you add more nodes, the total bandwidth of the network gets higher because not every node needs to talk to every other node. So yeah, I would say with these 400 or 500 nodes that we have right now, we're definitely fine for first use cases. I would definitely expect that to grow 10 or 100x once we see actual web traffic going through this, because So far we're talking about Web3. The web and what VPNs deal with is so much bigger than any of this. Like when we looked, for example, at like some numbers of traffic or even revenue, right? The revenue of the VPN space is 45 billion. Like if we talk about even Ethereum and all of that, that's a joke compared to the revenue of that, right? So yeah, please run nodes. Please get a DApp node because we will rely on you guys.
We have 1 minute left if we have another question for Sebastian.
I was just wondering, how do you see adoption of those privacy technologies? Like, who do you think will drive that adoption? Will it be the dApps that integrate this JavaScript library to protect their users? Will it be the users themselves installing plugins to use the VPN? How do you see the split there between individual and kind of dApp responsibility? Yeah,
that's a good question. So I'm a strong proponent of privacy by default. We have to move away from only the North Koreans use Tornado Cash to all of us use Tornado Cash by default, because that's the only ethical right way to go. And everybody has to use on-chain privacy. Everybody has to use transport privacy. It needs to be privacy by default. There is no other way to go. Now, how do we get there? In some first steps is going to be a tough one. So because there's multiple ways how you can do it, right? So with this JS library, that's a way that we can do today. But that's only going to be selectively for some dApps that integrate it. So if the dApps integrate it, that's the way to go. It's seamless for the user. But if some dApps don't get their act together and are not sufficiently private, users can always upgrade by installing a local client. So I kind of like that.
Thank you so much, Sebastian.
Thank you.